In class 12th, I am taking a very important topic, that is the electrical resistance. So far I have told you the Ohm's law, the derivation of Ohm's law, and that the key points of the Ohm's law. And now I will tell you about the electrical resistance. It is the property at specific temperature which opposes the flow of current in conductor. And this is the inherent property. Resistance is inherent property of all substances whether conducting or non-conducting. It means that all the substances have the resistance. Some are having very high resistance, some are having very low resistance, and some are between them, very high and very low. So the resistance of the conductors is low and the resistance of the insulators is very high. So R conductor is less than R insulator. Resistance of conductor is less than the resistance of insulator. The property of resistance is similar to the mechanical friction, which opposes the relative velocity of objects. तो जैसे रेजिस्टेंस अपोज करता है, that opposes the flow of the current, like that. This is the equivalent to the mechanical friction. Mechanical friction also opposes the relative velocity of the particle or of the object moving on the some surface. So this is very similar to that one. the resistance in conductors is produced due to collision of moving electrons with positive ions. Positive ions. The electrons lost their energy in collision, which gives the resistance. Origin of resistance. So, how this is produced? Because when the electron strike with the positive ions, they lost some of their energy. Because of that, there is the resistance. So this hindrance produced by the positive ions is the resistance. So now you will be thinking that why are there positive ions in the conductor? You know that every atom contains the electrons moving in the circular path around the nucleus. For a single atom, these orbits are well defined and electron move without any kind of interaction with the other atoms. But in a crystal, there are a large number of atoms, and as a result, these atoms are overlapping. So there is overlapping of the energy orbits of the different atoms. When this overlapping takes place, then the electron in the outermost orbit of the atom get free, and thus a large number of electrons are produced, which make the free electron cloud. When electron has been lost by the atom, then it becomes positive charge, and all these positive charges make a arrangement which is very systematic and regular. This arrangement is called the lattice. So when the electron is there, then this is attracted by the positive ion. So when the electron flows, it has to overcome that attraction force. So in that, it has to lose some energy, and this energy causes the resistance. So what we have? The electron will move with what the required velocity is not equal to the required velocity, but this is less than that. So the electron, while they are moving in the conductor, they have to face the collision with the positive ions, and this collision in the positive produced by the positive ions gives the resistance to the conductor. So this is what I have written, that the electron lost their energy in collision, which gives the origin of the resistance. the resistance is determined by two factors. Number one, geometry. Of substance, and number two, material of substance. Geometry means what? The length, area. So geometry, whether the given conductor is very long or very short, or it is thick or this is thin, then this is all about the geometry of the conductor or the substance of the substance. And second, the material of the substance. So what? Well, the conductor is made of which kind of the material? Either this is the conducting or non-conducting, or this is the alloy. The factors affecting the resistance. Now we have this R is equal to ml upon NAE square tau. This we know. So thus there are four factors. One is the length. Larger the length, larger the resistance. Because when the length is increased, then the electron collides with number of positive ions. So the more energy is lost. And moreover, the area of cross section. So resistance, that's number one, length L, number two, area, cross sectional area, area A. Larger the area, less is the resistance. Because when we take the thick conductor, then what happens? The space is more, so they can easily go through the space and they feel the less resistance. And number three, temperature. And number four, that is the material. Now I take one by one. Resistance increases by increase of length. By increasing the length of conductor. It means that less is the length, less the resistance, more is the length, more is the this resistance. So what we have, that in case of, suppose we are having this I take this is now current, this is now resistance. So by what we have, here is more resistance, then less current. This is now I. Less current. And if suppose we are having like this, this is now current, so here we have less resistance. More current. So current increases when the resistance is lowered, and current decreases when resistance is increased. So when this length is increased, then what happens? The electron strikes with more positive ions. By increasing the length of conductor, the electron collides with large number of positive ions. So resistance increases. This is what about the length. And in case of area of cross section, if cross-sectional area is increased, the resistance decreases. Because there is large space for electron to move in conductor. So what we have, that we can visualize it here with the help of this diagram. This is like this. Let me make it first. This is a thin conductor. Thin conductor. Thin conductor. Here is less space. So more resistance. And if suppose we are having like this, these are I am showing you. This is what the positive ones. This is like this. This is the thick conductor. Thick conductor. So more space. You are looking at more space here, and the less resistance. Less resistance. So this is what, if the conductor is taken thin, the resistance is more because the space is less for the electron to move, and here if you take the thick conductor, then the space is more, so electron move easily, and they have the low resistance. The conductor has the low resistance. So this I have told that how the resistance increases or decreases when the conductor is taken thin or the thick, and also about this length, that when the length is increased, the electron collide with large number of positive ions, so the resistance increases. And what happens when the temperature increased? By increasing temperature, the electrons collide more frequently with positive ions in conductor. So resistance relaxation time tau decreases and resistance increases. तो क्या होता है, जब टेम्परेचर इंक्रीज करते हैं तो the electron become more and more agitated. So they collide with the positive ions more frequently. In that way they lost the energy. And what happens that really is that when they collide more frequently, then the relaxation time decreases. So because of that the resistance increases. So this is what the effect of the temperature when this is raised or increased or decreased, and that affects the resistance of the conductor. And I will tell you that the electron density is different in the different conductors. This is about temperature. Then the material, the difference. Materials have different electron density. Electron density N. That I told you then in the expression of resistance. So the material having a large number of electron density. If electron density is very high, then the resistance will be very less. If electron density is very less, the resistance will be very high. The material having high electron density possess low resistance. इसका उल्टा, जब इसकी इलेक्ट्रॉन डेंसिटी कम होती है तो रेजिस्टेंस बढ़ जाता है अपने आप. तो उसमें जो एक्सप्रेशन है उसमें जो आ रहा है n, r is proportional to 1 upon n. So when n is more, r is less. n is less, r is more. So this is why that now you can in case of the conductors, silver is the best conductor, because the electron density in silver is very high. And then we come to the next one is the copper. Copper has the electron density less than that of silver. So copper is next conductor which have the very less resistance. Because of that, the silver being very costly, it cannot be used in the making of the electrical circuit. So copper is generally used in making the electrical circuit, whether it is at the home or this is some the electronic circuit. So there we use the copper wires. And nowadays the aluminum being of less costly, so some of the electricians also use the copper wires, these the aluminum wires. In this way, the material which have very high electron density have very less electrical resistance. So in case of material, here we are having this R is proportional to 1 upon what? tau. R is proportional to 1 नहीं ये not here but this is now here. This R is proportional to 1 upon tau. This is now here. And in case of this one, what we have? This R is proportional to 1 upon n. This is now what the relationship R and n. So this I told you about the resistance when and now I will tell you that what are the factors that do not affect the resistance. The factors not affecting the resistance. So there, except to all the 4 factors, no other factor affect the resistance. Except length, cross-sectional area, temperature, and material, no other factor. No other factor affects the resistance. No other factor affects the resistance. So, not affecting factors. This is now pressure, mass, capacitance, and this is what we have the density, etc. These are the factors do not affect the resistance. So there are only 4 factors. Remember only 4 factors: length, area of cross section, and that material and the temperature. Except these 4 factors, no other factor affect the resistance. So whether we take the pressure or mass or density or this capacitance or any other physical quantity, that will not affect this resistance. Similarly, if we are taking the velocity, acceleration, force, these are useless factors for the resistance. So I think this will give you a good knowledge that what happens when the resistance is increased or decreased, and moreover you can find that the factors which do not affect the resistance of the conductor. And you can see that the resistance I have told you that for conductor is less than the resistance of the insulators. So this is what the material. And insulators do not have the free electrons, so there is no flow of the current. So they are bad conductor to the electricity. So this is about the electrical resistance. Thank you.